Alright, welcome to another video. Got a little makeshift lab here at my night job, so I'm putting some things together. The point of all this, and I've already tested, it's working, so this is great. But the point of all this is to start to control lights and other devices via the Raspberry Pi using relay switches. Power is through your normal plugs here. Yes, this is for power. It's not white. I chose red because, you know, it's red. But unbeknownst to me, what's it called? What is it? RGB? That's kind of funny. Anyways, my community will know what that means. So I got a four port relay switch here. Watch the YouTube video. I have my red lead here connected to 5 volt on the back of the Raspberry Pi here, and I have a I think I forgot the name of the company. It's like electronic something, I forget. You can find these on their, it's Raspberry Pi screw-in GPIO terminals, but you can find them on Amazon. Decent price, probably like 17 bucks, I believe. So the red lead is from the, is it gonna focus? The red lead is from the JD VCC to the 5 volt, and then the orange lead is from VCC to the 3.3 volt. Over here is where some of the magic happens. The green is ground, and that leads to a ground on the back of my Raspberry Pi here. And the brown is IN1, which is the input here, right there. So that's going to control the first GPI, first relay point, I guess. I don't know. But it's going to control the first relay point, and that's marked over here. Sorry for the bad lighting here in this office. It's like really dim. And then this is how it looks on the back. I like these screw-in terminals. I can do as much as I want, especially for testing. Makes things a lot cleaner. You know, you can get your whole bag of leads here from Amazon, and they'll have male to male, female to female, male to female. So that works out very well. So this is a female end of this connector and to a male end of that connector there. On this side here, this is what controls the power in terms of like supply, or this controls the completion of the circuit. So this side, okay, hold on guys, hold on. So it's okay. All right, cool. So if I'm looking at this from this side of the relay, the right hand, there we go. The right-handed, or if I'm looking at it from this angle here, the right side, or the middle, out of these 3 connectors here, these screw-in terminals here, the middle actually goes to the power outlet, or to our plug. And this plug is wired up, and it tells you where to plug everything in. You'll see a green screw in this inside of it. These I bought them at Home Depot today. And you just unscrew them, and then inside it has like the green lead, and then it'll tell you black and white. In my case, black and red. But it'll tell you where to go put it in there. And then I went ahead and plugged it in. This is powering the Raspberry Pi for right now, cell phone charger. And this is my light. This is a non-grow light. This is just a regular light. So I'm just using this as opposed to a grow light, because I thought it could be used for growing. And the lady said, no, it can't be. And I was like, oh, okay. Well, I'll get them anyway, because I can always use them for my salon anyway. So that'll work nonetheless. And then if I'm looking out of these 3 connectors, far right, middle, and then left, this left side connector will actually go to my power supply cable here, and this is how I wrapped everything up. Again, quick and dirty. What I'll be doing now after I finish this video is start to do some heat shrink wrapping with my new boom. Got an actual gun here. What's it called? A heat gun. So this is probably about 20 bucks, I believe. Yeah, about 20 bucks. They have like $80 ones. I was thinking about buying it. And the lady was like, lady at Home Depot was like, oh, no, there's other ones, and you don't really need that much power. You should be good. And they work perfectly fine. So, $20 heat gun, brand new. I'll test it out here after this. So got everything. This is how I have everything wired up. I'm sorry it doesn't look that clean. This is just, again, kind of labbing it up. It's kind of short with some of these cables. Some cables are too long in the wrong places. But this is a LED light, and then it goes into a connector, a little pigtail connector there. So that's a 3-prong pigtail connector. So with this, you know, it's a 4-foot light, nothing special, nothing crazy. We use them at the shop. They're low power. They're really good, bright as hell, which you'll see here in a moment. Or bright as heaven. I don't know. I don't know if hell is that bright. Anyways, hopefully I don't find out. So I got this flip. Oh shoot! Dropped the phone. Hey, we're back. All right. So I want that right side up. On here. Oh, what is that for? Anyways, so got this is a test unit I've been using. I'll scroll up here so we can see some of the code. All right. Got this off a YouTube video. I'm going to link it in the description just so other people can watch it. It's a lot cleaner than mine. The gentleman in there explained everything very, very well, and how to actually get everything cabled up. So just go into a Python 3 shell. I'm going to make this a script later on. The way I have to make it a script, though, is that, or the way I have to script it is to make sure that I can actually do input on any one of these GPIO pins, because I want to actually control water pumps, lights, and other devices without having to get, like, say, I can actually get a APC power strip that'll actually do the powering on and off as well via IP, or over the network, I should say, which might be good for other devices that don't, you know, won't wire in well, which I'm not sure. I haven't ran into a problem yet, so, but that remains to be seen. So first command, Python 3, which you can see the second command there. First command is Cron Tab E, but I was doing some work. I had to shut something off. So Python 3, import rpi.gpio. Let's focus here. Yeah, import rpi.gpio as GPIO. Then GPIO.setMode, GPIO.board. Of course, that's wrapped into parentheses, and you can see it there. GPIO.setup 32, comma, GPIO.out, and then GPIO.high, and that turns it off. So when it's in high, it's off, and when it's in low, it turns the actual relay on. So what I'm going to do here is demonstrate high, and as you can see, we have no light. Then I'm going to go up and trust that I'm pressing enter, but boom, it turns on our light. And then I go back. I was complaining about lighting. Now I'm complaining about lighting again because now this shit is way too bright. And back to high. Oh, as you can see here on the relay switch, it's actually lit. You see a little red dot there, or the red light there. So that's up and running. And this is turning it back to high, dot high. And that switches it off. And you don't hear the red, you don't see the red dot anymore. Let's turn it on. You'll see what happens to the relay. You hear that clicking sound, and well, if I was a bat, I'd be blind right now. But turns that back on, and then high again, cuts that off. So yeah, that's Raspberry Pi controlling the lights. one of the many videos that they have online about this. But you can control things like the first article I saw was controlling a toaster. And then the video I saw, you know, you can control just about anything. There are things that require a little bit more voltage in terms of like the relays that require more voltage, like 12-volt relays. I don't really need anything like that. I just need something to continue the circuit and pop lights on and pop pumps on and stuff like that. I think I will run into a problem when I have like larger things on the network, but hopefully I can get like say AC units or fans or something like that where I can control, get a unit that can take higher voltage. Again, I'm not an electrical engineer, so I could be saying this wrong, but I'm thinking I'm going to need a better relay board to handle higher voltage as it's flowing through the relay so it doesn't melt it. So, and I also have not tested this for long term, so I don't know how this is going to actually work. I don't know the rating of this light. Actually, I think it might be on the back of it in terms of power consumption. Oh, wait. Okay. I got this from a company here in Florida, local to me. So 24-watt strip. It's 4 foot. Okay. Hold on. Let me look not through the camera. It's 24 amp. Okay. 24 pieces. Yeah, it doesn't really say what watt, how many volts. But I think you can actually just do the conversion if you multiply the amperage times the wattage equals the voltage or something like that. 277 VAC. Yeah, that's probably not the case. Oh, one thing is cool about these lights is you can actually chain them together, so I can have multiple lights like this hooked up together. So this is good for general lighting, but definitely not good for grow lighting because it's just not going to give you all the different color spectrums that you're going to need for your plants. But anyways, this works. I'm learning as I go along here, so if anybody has any corrections of can correct me on some of the things that I said improperly, please do so below. That'd be great. But yeah, on, off. Didn't take too long to set this up, by the way. The videos were great. I was watching YouTube videos, which made it take a little bit longer, just because I was watching some tow videos, which are kind of funny. But yeah, this is it. This is also my traveling toolbox here, where I have most of my stuff, or some of the stuff. I don't have it all. But after this, I'll be watching some videos on MongoDB and learning that. And yes, that's my laptop bag. I like the colors. Screw y'all. I have people make fun of me that like I have my customers make fun of me about that all the time. I don't really care that. She's like, oh, you know, like I have customers. It's like, oh, you know, Mike, you know, I like that bag. It's kind of feminine though. And I was like, yeah. I got nothing else to say. I just usually accept it. On. And off.